Good morning, seventh graders. So today we're going to try our first lesson using the distance learning. We're going to do lesson 6.2, which is rate of change and slope. What I've done for you for this first lesson is I have printed out the PDF of the Smartboard lesson that I would normally be using on the board. And we're going to go through it together this way with me writing directly on the PDF. I also have a whiteboard at home. And the next lesson we do, I'll probably try it on the whiteboard. Just need some feedback from you guys to let me know what you prefer. If you like it this way or if you like the whiteboard. So just let me know once it's done, once we've done both, okay? And we're gonna get started. So we're using GoMath for this. You can follow along in your textbooks if you have them, or you can do the same thing that I'm doing, which I kind of suggest. I did upload this onto your daily agenda. You can print it out and follow along with me. All right, so let's start. So we begin with this explore activity, investigating the rates of change. A rate of change is a ratio of the amount of change in the dependent variable, which is the output, to the change in the independent variable, which is the input. Remember from last year that the dependent variable, that's your y, and the independent variable, that's your x, okay? When we look at a table, the input's usually on top and the output's usually in the bottom. So we're thinking about x's and y's, which I'd like you to start. The x would be on the top and the y would be on the bottom. So when we're looking at tables like this, we're going to be able to decide what the rate of change is by looking at the values from x to y, the input to the output, okay? So example 1, Eve keeps a record of the number of lawns that she's mowed and the money she has earned. We're going to decide whether the rate of change is constant or variable. So that means, remember, the constant means it's staying the same. If it's variable, it's changing. Okay, so first we're going to decide what's the input and what's the output. If you're following along with what I said, x on top, then that means the input is the number of lawns, and the output is the amount of money earned. Okay? So in order to find the rate of the change, what we're going to do is we're going to figure out what the change is in the money that she earned, divided by the change in the lawns that she mowed, okay? So basically we're taking 2 points from the table. We're gonna see the change in the amount that she earned. So we're doing 45 minus 15. That's how we find the change, by subtracting, right? And then we take the change in the lawns, which is 3 minus 1. And we're gonna divide those two numbers. So 45 minus 15 is gonna give us 30. Over 3 minus 1 is 2. 30 divided by 2 is 15. Okay? Now we're going to check from day 2 to 3. So now we're going to look at these two values. We're going to do the same thing. We're going to see how much the amount earned changed. So we're going to do, oh, don't mind that noise. Those are my crazy cats. 90 minus 45 over the change in the days, number of lawns, which is 6 minus 3, which is already filled out for us. Okay, and now in this case, we're going to get 45 over 3. When we divide 45 by 3, we get 15. Okay, of course, don't forget you can use your calculators for all of this. Finally, we're looking from day 3 to 4, so we're looking at the change again between the amount earned. So that's going to be 120 minus 90, and then it's going to be over 8 minus 6. Okay, so now 120 minus 90, that's going to give us 30 again. And 8 minus 6 gives us 2. 30 divided by 2 is 15. So what we can see is that the rate of change each time was 15. So if you return back to the question, is that rate of change constant or variable? If it's staying the same each time, then that means it's constant. Okay, so the rates of change are constant, and the amount that Eve is earning each time she mows a lawn is $15. Okay, so now we're going to do the your turn, all right? So we're going to decide, first of all, what the rates of change are here, and we're going to decide if it's constant or variable. So again, if we're looking at a table, usually the first row or the first column is your x value, the second one is your y value. One thing to remember is that time no matter what, is always an independent variable. So if you're not sure which one is your independent and which one is your dependent variable, any measurement of time is always, always, always going to be your independent variable. Okay? So the table shows the approximate height of a football after it's kicked. We're going to decide whether the rate of change or rates of change, are constant or variable. So what you're doing is you're looking at two at a time, right? So we're going to do these two first. So we're doing the change in the y values, and then we're going to divide that by the change in the x values, which is the same thing we did in the previous example. So we're doing 18 minus 0 over 0.5 minus 0. Okay, so that gives me 18 over 0.5, which is really 18 divided by a half, which is really 18 times 2, which is 36. Okay, so what I'm going to have you guys do is I'm going to have you take a second and we'll set these up, and you guys are going to try it on your own, and then you will compare it to my answers in one moment. So the second group is going to be 31 minus 18 over 1.5 minus 0.5. So I'll give you a second to try that out. My cats are crazy. Okay, so if you've done it yourself now, you'll see that when you do 31 minus 18, you get 13 over 1.5 minus 0.5 is 1. So your rate of change is 13. Now that you only have to do these two, because now we can see if this was constant, the rate of change would have been the same. So 13 is not the same as 36. And so that means that the rate of change is variable. So now we're going to move on to using graphs to find the rates of change. This is a really, really important concept as we move into algebra. So basically we're going to be doing the exact same thing. We're going to be looking at 2 points, except instead of getting them from a table, we're getting them from the graph. Remember that every point is of the form x comma y. So when you pick a point, no matter what it is, the first one is x, the second one's y. Okay? So all we have to do is pick 2 points, and then we find the change in the y values and divide it by the change in the x values. So they're walking us through this. They want us to find the rate of change from 1 hour to 2 hours. So in order to do that, I'm looking for where x is 1 and x is 2. So those are these 2 points. Okay, and I'm going to first subtract the 2 y values. So that's 30 minus, and as you can see, the second y value is 15. And they've already filled out the x's for us, 2 minus 1. Okay, so 30 minus 15 is 15, and 2 minus 1 is 1. 15 divided by 1 is 15. So our first rate of change would be 15 miles per hour. Now they want us to find the rate of change from 1 hour to now 4 hours, so we're skipping all the way up here. Okay, so I'm going to write those points separately over here just so that you can see it. 115 and 460. So we're going to do the change in the y values first. So I have 60 and 15. So I'm going to do 60 minus 15 over, now the x value is 4 minus 1. Okay, so when I do 60 minus 15, I get 45. And when I get 4 minus 1, I get 3. 45 divided by 3 is again 15 miles per hour. So far I have a constant rate of change. If you've looked at your graph and you remember what we talked about with proportional relationships, we would have already known this is a constant rate of change because it's a straight line and it goes through the origin. So we know it's a proportional relationship, which means all of these rates of change will be the same. Okay, now finally we're going to find it from 2 to 4 hours. So I'm going to look at 2 and 4. So let's write those points here so it's a little clearer. 2 comma 30 and 4 60. So again, I'm doing the change in the y's. So it's 60 minus 30 and then 4 minus 2. 60 minus 30 is 30. 4 minus 2 is 2. 30 divided by 15, 2 is 15. So as you can see, 15 each time we have a constant rate of change. So now we're going to talk about what we just did, but in terms of a linear equation. When you have a constant rate of change, in other words, when we did the rates of change and we found that they were the same each time, what that really means is that we have a linear equation or a line. That means that we have a slope, okay? The slope measures the steepness of the line, how fast it's going up or how fast it's going down. You can find the slope from a graph by counting. So you could look at 2 points on the graph, on the line, and see how many how many times you'd have to go up and over to get to that next line. That's called the rise over the run. Okay, so what you do is you pick any 2 points. I could start here and I say, okay, how many do I need to go up to get to the next point? 1, 2, now I'm even with that next point, so that means I'm going up 2, and now I'm gonna have to go over 1, 2, 3, up 2 over 3, and I would write that in terms of the rise over the run. Up 2 over 3, the up tells me it's positive, so it's going to be positive 2 over 3, and that would be my slope. Now you can also find the slope using basically what we were doing before with the tables. You take the 2 points and you look at the change in the y values and the change of the x values. So basically what we're doing is we're taking 2 points. Let's just use an example here, 1, 2, and 2, 4, okay? This is our first point, right? This one's our second point. We knew that every single point is of the form x, y. So I've got 2 x's and 2 y's here. If this is my first point, then that would make this x1 and y1. And if this is my second point, this would make this x2 and y2. So what we did before is exactly the same. We decided what the change in the y's were. Look at the formula. It's y2 minus y1. That's the same thing we did before. So if we were following this, we would do 4 minus 2, y2 minus y1, divided by x2 minus x1, or the changes in the x2 minus 1. And then we would just do top and bottom separately. 4 minus 2 is 2, over 2 minus 1 is 1, 2 over 1 is 2. And that's another way of finding the slope. Okay, slope in the linear equation is given by m. Okay guys, so I'm skipping over example 2, just in the interest of time, and we're gonna do the your turn together. So what we've got is this graph that's showing the rate at which water is leaking from a tank, okay? The slope of the line gives the leaking rate in gallons per minute. We're gonna find the slope of the line. So they're giving us a spot to fill in the rise and the run. They're very clearly showing us 2 points here. So to count the rise and the run, remember that it's rise over the run, okay? Remember to do this, we're counting up and over. So I need to see, sorry, my hand is shaking. I need to see how many times I need to go up to get even with the next point. So that's gonna be 1, 2, 3. So I went up 3, and now I have to go over 1, 2, 3, 4. So I went up 3 and over 4. And written, so the rise again, sorry, that was up 3. So that's a positive 3. And over 4, 4. And then to write that as my slope, if it's up 3, that's positive, over 4. That's my slope, okay? I'm just gonna show you one time how to do this with the change in y over change in x formula, which is m equals y2 minus y1 over x2 minus x1. In order to do this, I just have to say what these 2 points are. So this point is 4, 3. 4, 3 is my first point, and my second point is 8, 6. Okay, I'm going to do this the exact same way that I did it before. This is point 1. This is point 2. I've got x, y, x, y. Since this is point 1, this is x1, y1. Since this is point 2, this is x2, y2. So I'm doing the change in the y values first. y2 minus y1. So m is equal to 6 minus 3 over the change in the x's, 8 minus 4, x2 minus x1. So this gives me 3 over 4. So as you can see, you get the same thing either way, no matter which method we choose. Guys, we're gonna do more with slope tomorrow. This is a 2-part lesson. So if this is not 100% yet, don't worry too much, just practice. And tomorrow we're gonna do just straight up practicing with graphs and using this formula, okay? And it's gonna be much clearer. As far as the practice goes, I think I gave you guys IXL, so you can ignore this. For all of the classwork, make sure, and the homework, so to speak, make sure that you're checking the daily agenda, okay? The daily agenda has exactly what you need to do. And that's it, so have fun.